All right, I think we can get started. Let's see. My update for this week is that the multi-core branch basically works. It's completing IOs. So I should have that pull request out in the next day or two. I'm mainly blocked on that bug. I guess vstart is just crashing with Seastore during MakeFS. Not sure why debugging that, but that's on main, not on the multi-core branch. And then I have fixes out for these two. If Chudney in particular, the first one there, I think might be the fix for the bug you were hitting. If you're still seeing hung IOs. That's it for me. Jinyu?
Hello?
Yeah, go ahead.
Let me share my recent work on map range remove. And I will need to share my screen. Okay. Can you see my screen?
Yep.
This is my recent work last month, and this is a subtree in OMAP. Subtree in OMAP tree. My target is to decrease node loads and adjusting and rendering memory copy. So that is to say, we can only adjust bound nodes for each layer in the whole tree and do not load leaf nodes and erase key in a range directly instead of one by one. But there's some problem, and that is we cannot reuse the recursive logics because of cross-parent adjust. We need level traversal. That is to say, for example, if we directly range remove an amount of nodes, and then this R1 nodes don't have brothers, and this R1 nodes don't have brothers too. So he cannot, he has no brother, so he cannot merge with his brother. So we should cross-parent. Maybe there is another subtree in his left, so he should merge with the left nodes, but that's cross-parent. So the past recursive method doesn't work. We need level traversal. Or we can just do not adjust the shape of the tree after range remove. Will be like appends. You say this line and this line, and the middle are all empty.
No, you need to maintain the tree
invariance.
invariance.
Better?
No, you need to maintain the tree invariance. Sorry.
Yes. So next, this is my step. First, the L and R is a bound nodes after range remove. So the first, for example, if we are in this layer, depth is equal to 2. First, we retire mid nodes, and before that, we should load it and record the logic address of next layer until the leaf node. We don't load leaf node. And retire mid nodes, and then erase keys in the range from the bound nodes. For example, the left 2 R2, the erase the keys, and then adjust his child nodes. For example, L2's child nodes L1, and maybe L1 need merge R1, so adjust him, and then calculate the status of this layer, that is L2 and R2. So there might meet many cases, special cases, and because we can't reuse the past logic, so plenty of code work. We need level traversal and then cross-parent merge, so we need level traversal, and then we need to record and update for location in each layer. You can say L, and the middle is a range remove range, and R. For L, this L is just candidates are L, and R. And for R is the same. The L and R and RR might be brother or not. They might be not in one node. And there are some special cases. And there's a whole tree. That is there is no left bound or right bound. And we need to implement the twice adjust. That is to say, after range remove, the L1 and the R1 might merge, but after it merge, it might still below mean in size. That is to say, we need a try adjust to balance or merge the RR. Yeah, the
Yep,
try to adjust. And what's more in OMAP is special. Because it's a variable length key. For example, we range remove this range, and if L1 is below mean, so we need balance a key from R1 to L1. So the parent of R1 need to update index key. So the parent might split overflow, so it needs to split. So that's more complicated because after that, we might continue merge after split of parents. So we should also handle this case. So that means we shouldn't split, although it will overflow when index key updating, and only after all this layer adjusting. The child layer adjusting end can we calculate the status of this node, and it might split or not. So to avoid node overflow in this situation, the simplest way is to allocate a temporary 2+ size OMAP node. This is just a temporary node. It can allow overflow because it's a 2+ size.
There is no reason to make that a cached extent, though. It can just be an intermediate data structure.
Yes, this is just a cached data structure. Or we can, in fact, we can realize in another way, but it's much more complicated. And this is also a corner case, and the range is only in one node. So this is some of the cases, not all the cases. It's pretty complex. So the difficulty is that we cannot reuse the recursive-based logics, and there are many complicated situation operations need to be considered and handled, especially in two-bound adjust, as you can see. So I searched for the what they do in Seastore, that they use RooksDB, and the RooksDB uses LSM tree, and it realizes by insert range tombstone block, and that is for LSM tree. And also search in Google Scholar, but there's no such solution.
I mean, I think you've correctly worked out the answer. You have to actually do the per layer merges. It's not actually that different from removing a key. It's just that it can span nodes. So you'll be duplicating a lot of logic that exists. My question is, what use case are we worried about performance of this in?
So
like there are some.
What I want. This is what I want to say. This is just for the OMAP range remove, and the Seastore, the interface need to implement this. Shui said, and so I think does it necessary to implement such complex logic for not such important feature in not critical IO paths?
That depends. Sorry, go ahead.
I have already realized the simple approach of OMAP range remove last week, and I will about to upstream later. This is a simple approach, and just list a range and remove it one by one. And this algorithm I worked last month, I have nearly finished the code of this perfect solution, but except handling the parent split caused by child's balancing case, we need to implement a temporary nodes to handle that. This is also complicated, and there's a lot of debugging and testing work for this per solution. So I think this is not in the crucial IO path, so I will continue to do this, but at a low priority, and aim at more performance-related regression. But if in a fixed length key tree, there will be no parent split caused by child's balancing case. So this can directly work. So if after introducing the max allocation size, so if we perhaps need range operations, so if we need, we can. I think it can directly work. That's all. That's all I'm thinking. So if only we use this in the OMAP OMAP tree, I don't think it does matter.
Okay. Well, the keys aren't fixed size, so that doesn't help. I can't think of any cases where we use remove key range or RBD.
Sam, when I do the when I do the
here's the interface. Can you see my? Oh, it only share my PowerPoint.
I mean, I'm aware of the interface method, and our Rados GW does use it. So it's not that there aren't any users; it's that there aren't any users we care about right now.
Hey, Sam.
Go ahead.
When I do the topology test for the Rados API, and I might 2 times the OMAP remove ranges, but not every time it happened. So only I test over maybe several times, but only maybe 2 times it triggered the OMAP remove ranges.
Well, wait a minute. We do need to implement it. It's a Rados interface function. Like, we do need an implementation. We just don't need an efficient one.
Yeah,
we can simply iterate
through
the keys and remove them. Yeah.
Yeah. So I have this. Go ahead.
Go ahead.
Yeah.
I was going to say. Yeah. I'll go ahead. This won't always be true. It's just that RBD specifically doesn't rely on this interface method. Both Ceph, the file system, and RGW do. And we will need an efficient implementation then. But for now, an inefficient one is probably okay. Especially if it allows us to spend time on something else. Okay, go ahead.
Yeah, I agree. I have discussed with Xiyu that he always considering the tree balance at every time, but I think it is not very important for us because the tree, if the tree is not balanced after remove the range, it will be adjusted to the next time we insert or remove the key from the OMAP tree, so it will not keep the status. Keep that situation.
Absolutely not. we absolutely do have to maintain the tree invariance at all times. The code that implements insertion and removal relies on the tree invariance already being true.
Yeah, but she just discussed it's very complex to keep the tree after keep the tree balance after the remove ranges.
I know that it's complicated. It's also worth it. If we don't keep it balanced,
there's only one step. There's only one step left to achieve that. That is the parent split in the OMAP tree. That is too complicated. So there's only one step left, and then other things I have realized.
So I would like to not worry about the complicated version of this for now, and simply implement the very simple iterate over keys and remove them using the existing.
Yeah, I will upstream it this week.
We have a... Okay, so sorry. Okay. I think the PG log trimming may benefit from this optimized range remove feature.
Yeah, I'm looking for that right now, and we don't actually use it.
Okay.
That's the one that's the one exception. If we actually use RM key range for PG log trim, then it matters. I'm looking for that now. Have you checked, Rehan? Do we already know?
Oh, I haven't checked that. I just thought when trimming, if we are not using...
we actually do.
Okay.
Yeah, I found it. It's in write log and missing without missing. Except that's the old one.
But I'm still curious about whether we will put PG logs in the OMAP eventually, or someday we will gonna move it out. I don't know.
Eventually, yes, but not yet.
Okay.
Okay, it looks like we actually do use OMAP key range and PG log, so we do need this to be efficient. I'm kind of ambivalent about this. I actually don't think this happens on the common path. I think we remove the keys individually. I need to read this in more detail. Junyu, in the meantime... Sorry, go ahead.
I say if the key length is fixed, and it will be much better.
Doesn't matter. You have to
better.
support the full interface. Sorry.
Oh, okay. Okay, go ahead.
I mean, if in order to do that, we would have to add a whole bunch of code that enforces that invariant, and I don't want to do that. Too much work. It's actually easier to support it correctly. If you do want to continue working on this, my suggestion is to write the test suite first. Do you understand what I mean?
I know. Write a test case first, and
yeah, in particular, you've identified a bunch of specific scenarios, and I would write the tests that would force those scenarios to happen.
Okay, my plan is continue, but at a low priority. If we just use this in OMAP, if we just use OMAP, because it's not.
My guess is that
bypass.
Eventually, when we're doing performance profiling on the OSD, this is going to show up as a major CPU usage, Shuihan. And at that point, that's the point at which we should invest resources in it.
Okay.
Does that make sense to you, Shuihan?
Yeah. Yes.
Okay, cool. Do you have anything else, Junho?
No, that's all.
All right, Aravind, how's it going?
Yeah. Hi. So I've been looking at benchmarking some of the on the ZNS drives, and I hit a couple of issues. I will raise the bugs for them, and also I had a few questions like do you have any data like in general from the telemetry data, how much storage like in deployments, in actual deployments, like how much is the storage full? Like, is it like 50% full on average, or like 80% full, or 90% full? Can we get any kind of information like that? Like, what is the storage usage in deployments?
No, not really. And to be honest, as Ceph clusters become very full, they behave badly for a lot of reasons. One of them is that you have a pseudo-random distribution of data usage across OSDs. So letting all of the OSDs in a cluster get above 80% is a problem to begin with, even before we start talking about Seastore. The second reason is that on ZNS drives in particular, there's likely to be more usable space on a ZNS drive than an equally priced conventional one.
Yeah.
So we're allowed to use more of the space for our own purposes.
Okay.
So I wouldn't expect us to allow devices to fill to more than 85% logically full.
Okay.
We wouldn't be able to do efficient garbage collection otherwise.
All right. So yeah, the one point I was asking was that on conventional devices, once it goes beyond certain 85-90%, beyond its over provisioning whatever has been provided, and once the device inside the device, the garbage collection kicks in, the device garbage collection SSD within SSD, then the performance of that drive would drop. But that would not happen with ZNS drives. Like, that is one of the places where ZNS can shine, kind of. Whether it is the bandwidth or the latencies, it would hold still compared to a conventional SSD. And we have seen that happen in other workloads. Yeah, so that's why I was just curious to check whether, like, in Ceph, how much is the clusters.
That's not really relevant here, though, right? Because our own garbage collection would start behaving badly if we allowed the drive to get that full, for pretty much the same reason, right?
Yeah.
The fact that the drive doesn't behave poorly doesn't really matter.
Yeah, that makes sense.
Yeah. Anyway, so I would say that at this stage of Seastore, we're certainly interested in being able to use as much of the drive as we practically can, but we don't expect to be able to use 100% of it. There will be a practical limit, and part of our job right now is to work out what that limit can be.
Yeah,
Does that make
sense? But it is a given that even though the drives gets at whatever level that we want to, like 85%, But then it is agreed that the IOs should still continue to happen, right? After it is 85% full and GC is running and it is reclaiming some space, and then once it is reclaiming space, it should be able to do further writes.
If you're seeing a hang, that's a bug. You need to debug it.
Yeah.
Yep.
Yeah. Thanks.
Like as long as the logical space is below the hard threshold, IO should happen at the same rate as garbage collection.
Right, but once garbage collection kicks in, and that when we hit that ratio, then IOs will reduce because GC is happening, right?
Yeah. You'll only be able to do writes at the rate at which garbage collection frees up space.
Right. Yeah.
And then eventually you'll hit the hard limit where we say no IO at all, because we need to retain whatever free space the OSD needs to do internal work.
Right. Yeah.
I think those are the soft and hard limits for the current Seastore, but I believe Yingchen was working on making that more sophisticated.
Right. Okay. Thanks. That's all I had. I'm looking at those issues and a couple more patches on refactoring the code, the ZNS code. So that's all the updates I had. Thank you.
Jianxin? Sorry if I didn't do that well. Can you hear me? Not sure.
Hello, Sam.
Hello.
This is Jianxin from Intel. I have something to discuss. Let me share my screen. Can you see it?
It's loading. Just a moment. Now I can see you. Go ahead.
Okay. Recently, I'm focused on the criminal Seastore random IO performance regression with large block data per file. We do benchmarking with different per file scenarios. As we can see, with different block size of per file increasing, the 4 gigabytes random rate performance drops quickly. The random write performance dropped a little too. So we suspect it is because the entire extent is read out when reading 4 gigabyte block. So we introduce the max allocation size to limit the size. We introduce the max allocation size to limit the size of extent in LBL tree. It is very simple. Specifically, when we insert a new extent, if it is larger than the threshold, we split it to some sections. Then we repeat to insert the section to the LBL tree. After this simple optimization, we can say it does work in the profile scenario. The performance go normally. But the simple implementation will lead the performance regression for megabits sequential write. Since the insertion couldn't be done parallel, maybe we need to add a new function like when you insert. Or shall we change the record to only get an extent we need other than the whole extent? Or how did Bluestore do it? Bluestore don't have that problem as we know. So what do you think? Thanks for your advice.
So it's not the read procedure that's the problem. It's that cached extents assume they have the full extent. So you would need to change basically all of the caching infrastructure to tolerate partially loaded extents. It's possible. It's also hard work. Range insert would be fine. There's no reason not to do that. I almost implemented it myself a while ago. So that would be fine.
You mean we need to change the cache architecture?
I'm saying when we load an extent off of disk, it goes into a data structure called a cached extent. Everything in all of Seastore assumes that the data in a cached extent is complete. So if you don't read the full cached extent, that invariant is violated. So it's possible, but you would need to generalize a lot of stuff. By contrast, simply adding a range insert, probably a good idea. There's no reason not to. Go ahead.
This is also what I said just now. Then that if after introducing max allocation size, the range operation might is necessary.
Yeah, probably. If you're just doing sequential insertions, you're spending a whole ton of CPU for no reason. It'll be really expensive. Yeah, that should be a very reasonable modification. Just, add unit tests for it.
Okay.
We probably are going to want to eventually generalize the caching infrastructure to tolerate partial extents. But that will require quite a bit more design.
Yeah.
Seems good. Do you have anything else? Xinjian, do you have anything else, or was that it? Okay.
Do you have any questions? No?
Anyway, that seems like a good approach. Tunmei, how's it going?
Yeah, so I figured out that the PG activation and blocker is always blocked there. So you said that the PR 1959 fixed that, right?
Yeah, I think that's exactly where I was seeing it block as well. So I think that's right.
Okay, so I will try it. I didn't know how to fix it. I just see that it's always blocked there. But
it was my mistake. When we requeue ops, we reuse the same pipeline handle and events.
So
and usually that's fine, but with certain orderings, the old copy of the op regrabs a mutex and then never drops it. So it leaks the mutex.
Oh, okay. So, but seems I still meet the other system hang. I found that it is unblocked, but still can't return to the client side. So I still need to test if still has the other problems. So that's all. I will try up here as soon as
Okay,
possible.
thanks. I'd appreciate it. That way, if it works, I'll know it actually works.
And that's all. I just spent some time at SDC last week. SDC is finished. I speaker for my colleague on the SDC.
That's good.
That's all.
All right. Is there anything else?
Oh,
I'm sorry, Rehan. I missed you. My fault.
Oh,
go ahead.
Okay. Okay. This week I finished debugging the code for pin set based on GAN mapping optimization. According to my results of my perf test, this pin set based GAN mapping optimization can offer about another 10% throughput improvement. So I've just submitted a draft for it. Right now I'm trying to beautify the code because it is a little bit ugly. I was too eager to see how the results would be. So I'm still adjusting the code. That's all for me.
And this is based on the other one. Okay, sounds good. Okay, cool. That's nice that it yields a nice performance improvement. All right, is there anything else? Did I miss anyone else? Okay, have a good week. Goodbye.
Bye-bye.
Bye.
Bye-bye.